Alright, so let's say you're in this diagram here, and the question says, consider the race between two boats above, one of mass m and one of mass 2m. They're both acted upon by a constant force of F. If both boats start at rest, which boat will have greater momentum at the end? To start, remember from momentum impulse theorem that J is equal to P2 minus P1, where J is the impulse, P2's momentum at point 2, and then P1's momentum at point 1. Note that momentum is equal to mass times velocity, so P1 is equal to mv1, and in our situation, the initial velocity for both boats is 0, so the initial momentum is going to be equal to 0, and that means that the impulse is just going to be equal to the momentum at point 2, given by this equation here. And if we remember that impulse can also be written in this form here with respect to the force acting on the object, we can note that our first equation for the impulse means that the momentum is equal to the impulse that accelerated the object to its present speed. And from this equation, impulse is the product of the net external force that accelerated the object and the time required for this acceleration. If we equate both these two equations, we arrive at this equation here, which represents the final momentum as a function of the force being applied from time 1 to time 2. If we apply this to our example, remember the question that we want to solve is which boat has the greater momentum at the finish line. And with our equation we just found, we need to find which momentum P2 is greater, P2 for the boat of mass m or P2 with the boat of mass 2m. We could first start by identifying that both boats have the same force applied, so this won't provide any difference in the final momentum. And then the second portion of the equation is the change in time T2 minus T1, and we know for both boats T1 is equal to 0. We can assume that the initial start time is the same, and T2, this is the unknown. We have to figure out which boat will get to the finish line first, and we can find this by using Newton's second law equation, which is force equal to mass times acceleration. So for boat 1, F is just going to be equal to ma, and if we isolate for the acceleration by multiplying both sides by 1 over m, we get this. So this is going to represent the acceleration of boat 1, and then for boat 2 we can do the same thing, except the mass of boat 2 is actually equal to 2m, and so we arrive at this answer for the acceleration of boat 2. If we compare, force divided by mass is greater than force divided by 2m, and we know that a1 is equal to the term on the left and a2 is equal to the term on the right. So with this equality, we can identify that the acceleration of boat 1 is going to be greater than the acceleration of boat 2. And since the first boat accelerates faster, this means that the first boat is going to finish the race faster. So that means that the T2, the final time of boat 1, is going to be less than the final time of boat 2. So what does this mean exactly? If we look at our equation and how it depends on T2, we know that for both boats T1 is equal to 0. We also know that the force is the same for both boats, but we know that T2 is smaller for boat 1. So that means the final momentum for boat 1 is going to be less than the final momentum for boat 2. So that means that therefore the boat with mass 2m has greater momentum at the finish line. And this makes sense since there's a larger impulse for boat 2. From the equation, we know that the larger time taken means larger impulse. And we know that impulse is also equal to the change in momentum. So this larger impulse also means a larger change in momentum. And that explains the behavior we see in the momentum of the two boats.